So one of the next things I want to learn more about is how do I build graphical output on my Zynq-7000 board that I put together. I've tried to get X11 to work. I cannot get it to work with the way that I have the video set up. And again, I'm using a circuit very similar to a Digilent, either a Zibo or an Arty, the Z7. Basically going straight out of my Zynq-7000 with the HDMI signals going out, and I'm using the Digilent HDMI driver for that. But I cannot get X11 to be happy with that, regardless of what configuration I try. So I'm just going to move on from that and say, okay, well, maybe I'm more like a console app here. What can I do in the console app? And what are there for utilities and ways that I can do some things graphically? And I definitely see that there's a lot of options out there for building menus and graphical console type of applications. But I thought it might be interesting to learn how do I do pixel level control if I want to just start doing my own thing on that HDMI output, or that canvas if I want to think of it that way. So here, what you're seeing is the HDMI output being captured, and I'm going to go ahead and log into my system. And I'm going to change into the user bin, and I've added a program here, and it is a frame buffer testing tool that I put together. And it's called FB test. And so I can go ahead and run it, and it'll just show me, what do I have for choices. I can say, show me the config. So I'll do an FB test, and I want to show config. And I let it basically prompt me, or I let the user specify, well, what frame buffer do you want to use? And maybe before I go further, let me just break out of that. If I go look at my dev folder, you'll see that I have an FB0, and that is the HDMI output that I'm working with. If I now come back in and I run this again, let's say show config, and I just press enter, that'll choose by default FB0. But then I just list out things, for example, what's referred to as the fixed screen info and the variable screen info. And I might be missing some info in here and have to figure out where to set it. And maybe that's part of the issue I'm running into with X11. And so that's some of the digging I'll do. But I'm now starting to programmatically pull back some of this information so I can really dig in deeper into it and see if I can understand what's going on. But you'll notice here that if I go down to variable screen width or variable screen info, there's an X res and a Y res. So I'm running 1280 by 720 on this output that's going basically into an HDMI capture device on my computer. If I go back to this tool, again, I can just, if I just run it without any params, it gives me the help. But then I can also do a test one. And maybe I'll just clear the screen real quick, and then I'll do a test one. Test one just simply animates this, red, green, blue, these blocks coming down the screen. So that's all that does. But then I also have test two, and test two just runs these little animated characters, software sprites, if you want to think of them that way, across the screen. And I've done a bunch of that stuff on my previous projects, again, going back to the 6502, 65816, the 286, 386. And there, I could render this stuff and right away try to render the next, frame in the animation. I tried doing that on this Zynq-7000, and it was so fast, it just jumped immediately to the last frame. There's no animation. I had to actually go in and put in delays to make it animate. But that's one test I've done here. And then I've also done a third test, which is just to load an image off of the installation, off the SD card. And so this is a 1280 by 720, 24-bit color image that I loaded. And the first time I loaded it, you can see it took 21, well, it went took 0.13 seconds, and it was at 21 megabytes per second. If I run it again, It comes back in the 140s, maybe up to 150. And I'm assuming that's caching of some sort that's happening in the Petalinux operating system. But all of that I'm doing from just an app I wrote. And maybe what I'll do here is pull up this. This is Eclipse. And I installed it just as a text editor. And what you're going to see in here is that I'm really editing this file called fbtest.c. And I'll just show you at a really high level what do I have in here. Let me just collapse all of this for a second. I know there's probably a keyboard shortcut to collapse everything. I'm going to do it the hard way. Now out in my system, a couple of things. In my Petalinux project, I did come in here and I did add my own layer. So this gets into the Yocto layers recipes, but I did that so that I could have this additional piece of software called Image Magic. But there's other things I've done, and I would come back to my meta user, and I did create another app. So in a previous video, I showed that I had created a flash LED app that flashes one of the LEDs on the board. But now I made this FB frame buffer test app, and it's got the BB file that goes with that, along with the C file, the make file. I have some sprite data I put into a separate file. And then I have a copy of the original image that I took, which was this one here, which is a JPEG format. So this is just a file I grabbed. And then I created just a raw RGB version of that. So basically it's not a JPEG, it's all of the raw data. And that's what, for now, I'm just loading up, is just that full raw file. Now, if I go back to this code, then once I created that app, of course, it creates a template from Xilinx, and I erased everything in there and put in this instead. And if I go through this, just to kind of give you an idea what I'm doing, I'm right away just checking, well, which argument did you choose, test 1, 2, 3, or the show config. If you did the show config, then I'm going to come in here and ask you. So you'll see some repeated code here that I'll pull out into a common function, a shared function later, but it's just asking, okay, which device do you want to use? FB0 is what I'm doing everything with for now. And then I try to open up that device. So I do an open and try to work with this frame buffer device. And that is just the /dev/FB0 that I'm directly working with. I think you can, copy things, echo things to that, and send out raw data to it, but I wanted to programmatically do something with it. So then I turn around and I get what's called the fixed screen info and the variable screen info back. And the way that that works is I basically say, okay, I want to go out and I've got this IO control, so generic IO operation. I'm going to work with that device, and I want to basically pull back this struct basically of information about the screen into these actually two variables, vinfo, and there's another one here that is right up here, finfo. So I got that. So fixed screen and then variable screen info, I pull those back. And after I pull them back, if there's no error, then I call a procedure that just simply prints out that screen info. And so up here I have a simple, you just pass it in and then it prints out what you saw on the screen earlier. So if I come back over here and I'll just clear this and I'll go back up, I had done a show config like this. I had selected that device, and I'll slide this off to the right so you can see it as I'm going through this, but this is just then printing out that information. So print out the fixed, print out the variable information so that I can see how is that frame buffer FB0 configured. And that might help me do some troubleshooting, like when I'm trying to get X11 up and running. I do have 1 or 2 errors with that, and one of the errors is something about invalid or missing screen info. So there might be some of these that need to be filled in, maybe from the device tree, that aren't being filled in, that should be filled in, that are causing problems. But that's a problem for another day. So that's what the show config does, and it just simply shows that information. And then I get down to the end of this and do some calculations, basically to get me my map to the device memory. And I say that, yep, I was able to map that, and you can see that down here on the output. And then I shut it all down. So I really don't do anything with it once I get it mapped. So this FBP is something I could then start working with, and that's a map to the memory, basically, of the video output, so I can work with that. But what I do in the tests, like test 1, so if I go back and run test 1 over here, and that was just this bar that kind of floats down. And what I did here in test 1 is really the exact same things up to this point. I try to open up the device. I try to get the screen info, because I do need some of that for calculations later. Calculate, what is the screen size based on that info. And then I get this FBP so that I can work with the memory. And then I start out by saying, okay, why don't you write a 0 to all of that memory, just to basically clear it out. Now a 0 would be for every pixel, and the 0 would represent a black. So it's a red, green, blue, basically set of data, 3 bytes of data, and a 0 is just saying I don't want any red, I don't want any green or blue, and that clears the screen. And then I've got a set of loops within loops within loops that basically come in here, and I've got one that does a little bit of clearing. So then as this thing falls down the screen, it's not leaving a trail behind. It's kind of clearing itself out as it goes back to black. But then I have this section here that is essentially creating these 3 colored boxes. And then within this other loop, it's just moving those 3 sets of boxes or rectangles down the screen as it goes. But basically, I'm just trying to get a position. Where do I want to draw something? And then I go out and I use the address of that memory, and I have some type of offset that I'm working with. But then in this case, it says, okay, at this location, I want to put in the color 0000FF. That ends up being red in my setup. So I've got the reds as the lowest byte, and then green as the next byte, and then blue as the next byte. That seems a little backwards to me, so I might want to double check that later, but right now that is how it is set. So the lowest byte of this is red, and then green, blue. So this is saying I want to build a blue box. That's what this loop right here is doing, is build that blue box, the red box is the first one I build, and you can see I'm going from y coordinates of 100 to 149, and then x coordinates of 500 to 599. That is essentially the coordinates of this box when it first comes up. As I run this, again, it starts way up high. And so the y position coming down 100, the x position coming over 500, that's where it would have started up here. And then it's just going to simply work through an increment through the y. So it's going to be pushing this stuff down. But then I do the same thing. Here's a box for the green, very similar. It's just instead of going from 1 to 149, I go from, or actually that's for the y, so that's the same for this first run, but then the x is in a different position. So instead of at 5 to 599, this is 6 to 699, and then the blue is 7 to 799. But all that's doing, this code is doing, is drawing those boxes, and then this outer loop is what's moving the whole thing down. And as it moves it down, it clears up the old one and then draws the new one. So I'll run that one more time. It's just this type of really simple thing. So that's what that test was. And then I went in and I created a test 2. And at test 2, this got a little more involved, but pretty fortunate that all the work I was doing on my 286 and 386SX, most of that, 80% of that was in C, and a bunch of it was in assembly. So the assembly stuff probably isn't going to come over very well, but all the C stuff, I can just bring over some of those functions and tweak them to make them work here. But if I run that second test, that's these guys running over here. So this was interesting. As it flipped to that, it must have flipped to a different, I have 4 frame buffers. So I suppose it's just working through those, and it got back to one that still had some stuff in it, which is interesting. I'm going to go ahead and clear the screen, and I'll just run it again. Okay, so there's my little guys running across, and what that is made up of is really 3 little representations. These are this animation is made up of three different layouts of this character. So it's not like there's a 20 frame sequence. It's a 3 frame sequence for the animation. So it's really simple. But over here, I do the same work. I connect, I get all the way down to where I want to start drawing things. I clear out the frame buffer. And then I clear out any edges of a previous sprite. So basically, this code isn't very intelligent yet, but as that sprite is moved to the right, I need to clear up what was previously there. So again, it doesn't leave a trail. So I just have some code that I call a little routine that clears out the trail. And then I have a call to a draw sprite. And I tell it, here's what I'm working with as far as that frame buffer is concerned. I want to draw a sprite at a certain position. Which sprite number do I want? And you'll notice as this goes, it's going to work through 3 sprite numbers, 0, 1, and 2. And so when it first comes in here, well, I suppose it's up higher. I've got it, this sprite num starts at 0, but then I go to 1, and then I go to 2, and then if it's at higher than that, I set it back to 0. So it's going 0, 1, 2, 0, 1, 2, 0, 1, 2. And essentially those sprites I'm pulling from over here. I just have some raw sprite data just right in a C file. And this is really containing the color for every pixel. So this would be 32 rows by 32 columns. And then I have, in this case, this was all code from my Intel 286 work I was doing. And you can see here, this is only 2 bytes of data. This isn't 3 bytes of data. But I wasn't going to bother rebuilding these sprites or doing anything like that. So I said, okay, that's fine. I'll just use the 2 byte, so 16-bit color sprites instead of a 24-bit. And when I go back over here, then when I do call this draw sprite, I get up here and I have basically code that goes through and says, okay, which sprite number do you want? And then for whatever sprite, whether it's 0, 1, or 2, then I call a draw pixel, and I tell it again, where am I working with, what frame buffer, where am I at, position within that, and then I go over to that sprite data, whether it's the first, second, or third piece of sprite data over here, and I go grab the specific pixel that I'm iterating through, grab the color, and then I want to put that color in and draw a pixel. But then when I go do a draw pixel, I'm actually converting the color that I read from that lookup over here into a 24-bit color. And so I just have a little routine that does that. This could all be put together, but I wanted to be able to read through it and just mentally keep track of this. So I bring in a 16-bit color, which is in a red, green, blue 565. That's what I was using in previous projects. But now this project, I'm doing an 888. So this code just simply says, take that 565, take those 5 bits, slide them to the most significant 5 bits of a byte, take these 6, slide them to be the 6 most significant, then the next 5. So that's my red, green, blue. Put it all back together into a 24-bit number, essentially, and that's what I'm going to put into that location out on the frame buffer. So that draws 1 pixel, but then the draw sprite is drawing the 32 by 32 pixels for that one, animated part of the sequence, one of 3. And then I clear it, move over a little bit, grab the next little sprite in the sequence of 3 and draw it. And again, if I pull this over, I run that again, that's all that this is doing. It's going from one to the other to the other. And it ends up that it was just going so fast with one. I thought let's have a few of them there and see if I can even notice a difference in speed. And no, this system's so fast that any of the stuff I was doing before in my 286SX or 386SX, this is just ridiculously fast compared to that. So, down here in this test, I ended up drawing 3 sets of sprites. That's why I'm clearing up after 3 different sets of sprites, that are all running across the screen. But at the end of each drawing of a sprite, these little characters here, I draw the 3 when they start off on the left. I then have it sleep for a little bit. If I don't put this in there, it's just almost instant. The sprites are off to the right. It just moves through so fast. Then I'm all done with getting to the edge of the screen, which is once it gets to this 1200 area as far as column or X position, then I just simply get out of this. I don't bother clearing them or anything. I just leave them on the screen. So that's what this one is doing. Just it's just some sequences I've built up for older work and kind of just brought them over, adjusted them a little bit, and off I go. So I'll go ahead and run the third one here. And that pulls up something like this. And showing you the code for that real quick, a couple of things. I had come out and added in to my Yocto layers, whatever it is. I had come in and set up my project spec, my own layer, and basically had it include this image magic. And so I came in here and set that up so that it would go download it and include it as part of my image. And so then on my system, actually once I boot it up, I do have access to that tool. Now part of that tool requires X11, but part of it doesn't. And one of the things you can do with that tool is just simply strip down images down to a raw, just the raw data. And so I took an image similar to this syntax. I basically said convert. That's part of that tool set. And I picked an image with a bird and I stripped it down to just the raw RGB. So not a JPEG format, but just an RGB. I did that once and then I included that, and you'll actually see that if I go into my app, project spec, and add a user, apps, and I go to my FB test, part of what I do here is I include a couple of these images, the actual source image, and then one that is just the RGB version. But I created that once with that tool set doing something like this. But once it's there, now I'm just kind of using it as a test. So I ask which device, and then I simply copy that raw file out to the output of the device. So in this case, dev FB0. So then I basically take that and copy that raw image over to this FB dev, which would have been dev/FB0 in this case. And that gets the image up on the screen. So I'm just doing a raw copy of the data, but I had used that image magic just to prepare real quickly an image without any of the unnecessary header data, just the raw data, so I could do something like this. Now down the road, I'll have to programmatically work with JPEGs and PNGs and things like that. But for now, I just wanted a quick test so that I could come in here and do something like this. So if I clear it and I run it again, that's what I'm getting for the output. And it's interesting to see too how quickly, once that file's cached, how quickly does it copy it over. So it grabbed that 2.8 megabytes in 0.02 seconds roughly. So 20 milliseconds for about 150 megabytes per second. But that's it. That's what I've got so far. So, what I have here though is enough that if I want to start doing a lot more graphical stuff, maybe even back all the way to one of my previous builds, I had actually even built a kind of a really basic Windows type of interface where you could have a start bar and things like that, and actually run stuff. And this is the type of foundational work I did to make that work, and just some of the basics like drawing different shapes and filling them and drawing lines and all of that work, stuff that I can bring over if I want to do that type of low-level stuff. But I do find that as I get into this, working with this is really not much different than on my 286 or 386. It's actually pretty straightforward. It's just getting an address to change the color and set that color. And now I can start working with that. So that's all I've got in this video, and I thought I would just kind of show that I can get in here, and it seems like being able to do things like graphic work like this, or going back to this previous type of stuff like test 2, I could start building out something, maybe a retro type of game on here, which I don't think would be too bad to do. Or maybe even I could find a couple of retro games that I could find source code in C and see if I couldn't build it to run on my Zynq-7000. That might be kind of interesting. One thing I have not done anything with yet on this board is sound. So that might be something that I use some of those GPIO signals coming out that I'm not using, that I was talking about in the last video. See if I could do something with generating sound of some sort. And maybe I would even go use one of the retro sound chips that I've used in the past, and use the GPIO just basically to control that, so that I can feed it sounds that are the retro style sound if that's what I want.